Hi, this is Jalen Murthy. Success is built, not gifted. Let's master maths step by step. To third episode of integration. In this, we will discuss two more very important formulae with explanation and derivation. Yes, in the previous one we have discussed formula 1, 2, 3. Here, fourth formula we are going to discuss integral of dx by root x square plus a square. Here, the substitution needed for x is equal to a tan theta because we have x square plus a square plus a square tan square theta. So all this derivation is going to come in the next slide. So the result of this particular integration dx by root x square plus a square is natural logarithm ln of x plus root x square plus a square plus constant of integration c. Okay, what is the key insight? This integral transitions from a radical form to a logarithmic expression, while the tangent substitution x equal to a tan theta can be used. An algebraic rationalization approach often provides a more direct path to the solution. Now, solution approach. Apply substitution x equal to a tan theta or use algebraic manipulation. One of them we can adopt. Simplify the radical expression carefully. The integral naturally converts to a logarithmic form. This standard result appears frequently in arc length and surface area problems. So this formula is essential for calculating arc lengths of curves and appears in physics when analyzing hyperbolic motion. Okay, let us look at the derivation part. Yes, we have taken let x equal to a tan theta. Dx is a secant square theta d theta. And the function given is 1 by root x square plus a square. Yes, substituting x equal to a tan theta x square is a square tan square theta. Therefore, we have 1 by root a square of 1 plus tan square theta, which is 1 by root a square secant square theta, or root getting cancelled with the squares. We get the base form 1 by a secant theta. So this is the function part, and dx part is of course a secant square theta d theta, and combining both of them we get a gets cancelled and secant square theta, 1 secant theta gets cancelled. Ultimately you are left with integral of secant theta d theta. We know that it is logarithm of secant theta plus tan theta plus a constant of integration. Okay. Now what is this tan theta and secant theta in terms of x and a? Yes, x is a tan theta is x by a. Secant theta is root of 1 plus tan square theta we know, which is root of 1 plus x square by a square, or simplified root x square plus a square whole divided by a. Now adding these two, we get x plus root x square plus a square whole divided by a. And we know that logarithm, whenever it is taken, log of m by n is log m minus log n. Therefore, logarithm of this expression with variables minus log a we are going to get. And k is constant of integration, k minus log a. If you take that itself is another constant that we are going to call c. Therefore, k minus log a I replace with c, and finally my integration will reduce to integral of dx by square root of x square plus a square equal to logarithm of, logarithm means is a natural logarithm, that's called ln, right? So ln of x plus root x square plus a square plus constant of integration. This is the derivation part of it. Hope it is clear. Fine. So we move on to the next important formula. Instead of x square minus x square plus a square, we have here x square minus a square. Let us see how it works out. the previous formula we have seen root of x square plus a square under root as a denominator, and here in the denominator we have root x square minus a square. So earlier we have taken x equal to a tan theta because there is a plus sign. Now we have to take x is equal to a secant theta because secant square theta minus 1 is tan square theta. So that fact will help us in letting x is equal to a secant theta. Right. So therefore the given integral dx by root x square minus a square equal to ln, the natural logarithm of x plus root x square minus a square plus c, the constant of integration. Now let us see how this can be derived in a proper way. Yeah, here we go. Let x equal to a secant theta. X square is a square secant square theta. X square minus a square is a square of secant square theta minus 1, which is a square tan square theta. And the root of that is a tan theta. Fine. So the expression has come to a tan theta. How about dx? X is a secant theta. Dx is a secant theta tan theta d theta. Therefore, operating upon both of them as a numerator and denominator, we get a tan theta get cancelled and simply integral of secant theta d theta. Exactly the what we got in formula 4, the same we are getting integral of secant secant theta d theta. Therefore, log of secant theta plus tan theta plus constant of integration, let us say k. I am not taking c directly because I need to operate upon logarithm of a on that. Okay. So now what is secant and tan in terms of x and a? So secant theta is x by a, tan theta is root secant square theta minus 1 root of x square minus a square by a. Adding them, you get x plus root x square minus a square by a. Logarithm of secant theta plus tan theta is logarithm of x plus root of x square minus a square minus log a, the way log of m by n is handled. Right. Therefore, integral of secant theta d theta is log of x plus root x square minus a square under mod absolute value plus k minus log a. Log a is also constant, therefore constant minus constant is another constant. Therefore, k minus log a I take as c. Fine. Therefore, my final derivation is completed. Integral of dx by root of x square minus a square is logarithm of absolute value x plus root of x square minus a square. Here logarithm is base e, that what we call is natural logarithm ln. So ln x plus root x square minus a square plus c is the integral value of this. Okay. Now, let us look at the concept summary. How concepts are arrived at. Whenever a square minus x square is there, you have to substitute x is equal to a sin theta. If a square plus x square, then x is equal to a tan theta. If it is x square minus a square, x is equal to a secant theta. This is the pattern in which you have to substitute values for x to different parameters so that the simplification will be arriving in a comfortable way, giving the results properly. Now, what are the key observations? Radical forms containing squares often lead to inverse trigonometric results. Logarithmic answers commonly arise after algebraic simplification. Recognition of patterns saves time and reduces errors. This is very important. And finally, there is a practice tip. Master these 5 standard integrals thoroughly. This episode and previous episode together we have totally 5 standard integrals. So that please master them thoroughly. They form the foundation for solving more complex integration problems and appear repeatedly in applications across physics, engineering, and advanced mathematics. So, Thank you. See you in next episode.